All right, welcome to This Explainer. Today, we're diving straight into a totally mind-bending paper by Dr. Ahmad Rihan that literally reimagines the fundamental fabric of our universe. Now, for over a century, quantum mechanics and relativity have been the twin pillars of modern physics, right? Yet, as we all know, they famously refuse to play nicely together. But what if the problem isn't the math, but rather our most basic assumptions about the geometry of reality itself? Today, we are looking at a Lorentz covariant effective field theory that challenges absolutely everything we thought we knew about empty space and the light traveling through it.
So let's kick things off by challenging pretty much everything standard textbook physics has taught us about the basic unit of light. You know the drill with standard quantum electrodynamics. We usually treat the photon as a zero-dimensional, point-like particle. And yeah, it's an incredibly useful mathematical abstraction, but it also leads to a cascade of infinite divergences that physicists constantly have to sweep under the rug using renormalization. Dr. Rihan's paper asks a pretty radical question. What if we stop treating light as a geometric dot and instead look at it as an actual physical structure?
And that right there brings us to the Helical-Filament Hypothesis. Dr. Rihan is proposing that light isn't just some tiny bullet shooting through an empty void. Instead, what if spacetime itself is actually this dense, dynamical network of null electromagnetic filaments? Within this framework, a photon is actually a finite-size helical excitation, a massless spin-1 spiral, winding directly around these microscopic filaments.
To really wrap our heads around this massive paradigm shift, we're going to hit 5 key areas today. First, rethinking the photon. Second, diving into the space-time filament web. Third, exploring energy as a fifth dimension. Fourth, seeing how this solves QED tensions. And finally, testing the hypothesis.
All right, Section 1. Rethinking the photon, going beyond point particles. Let's see how this both builds on and totally flips our standard view of physics.
This right here really hits the nail on the head when it comes to the core contrast. We are swapping out that paradox-inducing point particle of ordinary QED for a topologically protected spiral on a literal physical fabric of spacetime. The standard model tells us the vacuum is perfectly smooth and continuous, but we all know that at extreme ultraviolet energies, that assumption completely breaks down. The Helical-Filament Hypothesis fixes this by replacing that smooth vacuum with a dense, fluctuating web. The photon becomes an extended object with an actual transverse size, completely determined by the local filament's core radius. And this isn't just an aesthetic shift, It's a topological necessity that totally changes the geometry of how light propagates.
Moving on to Section 2, the space-time filament web. So, if space isn't just an empty void, what exactly is this web made of?
Well, the math describes this fabric using what physicists call a Kalb-Raman field. To put that into plain English, reality at its absolute smallest scale is this fluctuating, incredibly dense web of filaments. Think of it kind of like a microscopic, three-dimensional trampoline that actively weaves the fabric of space together. These filaments act as null world sheets, and get this, they are perfectly aligned with the light cone. To actually picture how light moves in this new model, we can break it down into a simple 3-step sequence. First up, the spacetime filament exists as a null geometric path. Second, the photon binds to this path like an excitation. And third, it propagates. But here is the kicker. Because the filament itself is null, meaning its geometry inherently dictates the speed of light, the photon travels at the exact speed of c automatically. There's literally no fine-tuning needed. As it moves, the photon's winding is mathematically encoded by a real phase field, and its classical value on array is the Euler angle.
Now this is where it gets really cool. How does this model explain color? Well, the observable energy is still the good old standard Planck value we know and love, but different colors simply represent how tightly that photon is spiraling around the filament. Think about it. An infrared photon has a super slow helical winding and a really wide pitch. Visible light is somewhere in the middle, but an ultraviolet photon, that has an incredibly rapid winding rate and a super tight pitch. It's all the exact same master formula. The only geometric distinction is the rate of that Euler phase winding.
Okay, Section 3, energy as a fifth dimension. We have officially reached the most conceptually thrilling part of Dr. Rihan's paper, because we are literally redefining energy itself.
If we take our old textbook physics concepts and map them directly to these new multidimensional realizations, we see something wild. In this hypothesis, energy is actually a compact fifth dimension. The math uses a Kaluza-Klein type metric, where the phase advances linearly with laboratory time along every single photon world line. meaning this fifth dimension is quite literally winding helically around the ordinary time axis. The electromagnetic filaments, they're the world sheets that fiber this fifth dimension right onto our standard spacetime.
Dr. Rehan puts it perfectly here, saying the observable photon energy is nothing other than the momentum in the compact fifth direction. So the absolutely crucial takeaway here is that the Euler helix around time is the fifth dimension, and the photon is just the energy traveling on that helix. Higher frequency light simply means a faster winding helix around time, carrying higher quantized momentum in that fifth direction. It's a beautiful way to perfectly unite our four-dimensional effective field theories with a five-dimensional geometric reality.
Which brings us to Section 4, Solving QED Tensions. Now, you might be asking yourself, why even go through all this trouble of adding dimensions and space-time webs if the old math works just fine? Well, because, as we all know, the old math is actually full of infinite contradictions.
This hypothesis is a total game changer because it elegantly resolves some massive headaches in modern physics. First off, it geometrically smooths out those pesky ultraviolet divergences. Second, the photon's masslessness isn't just some lucky accidental gauge symmetry anymore. It is a topological necessity because it's traveling on a null filament. Third, it keeps the universal speed of light constant without needing a preferred global frame, since the whole network is Lorentz covariant. Oh, and it also drastically shrinks our estimates for vacuum energy, taking an uncontrolled divergence and replacing it with a controlled, manageable quantity based on actual filament density.
Let's zoom in on that first point about divergences for a second. In standard QED, you know how loops diverge because point particles have literally zero size, right? It causes momentum integrals to just shoot off to infinity. But by replacing a point particle with a finite size helical excitation, those momentum integrals are naturally cut off by the physical transverse size of the filament's core. Boom! Power divergences suddenly become finite controllable expressions. The theory stays totally renormalizable, but now it has an actual physical justification. The counterterms represent physical properties like filament tension rather than abstract mathematical band-aids.
All right, final section, Section 5, Testing the Hypothesis. Because hey, this isn't just some abstract mathematical philosophy. The paper lays out real, concrete ways we can prove this in the lab.
Normally, the filament density in a standard vacuum is so extraordinarily low that we don't even notice these helical effects in our everyday lives. But if we look at highly specialized environments, like strong magnetic flux tubes where filament density is artificially cranked up, we should absolutely be able to measure a distinctive circular biorefringence using modern polarimetry. We might also see a fractional shift in the effective Planck constant using specific single-photon interferometers, or even catch glimpses of cosmological biorefringence out in the cosmic web using next-gen 21-centimeter intensity mapping.
And there's more. The filaments themselves experience what Dr. Rehan calls longitudinal breathing. Since time is realized as a collective, longitudinal oscillation of these null filaments, the local axis of the photon is essentially vibrating. This constant stretching and squeezing modulates the geometric phase of the photon, and since that phase modulation index scales with frequency, this breathing effect ramps up incredibly fast as photon energy increases.
What this means practically is that if we look really closely at high-energy ultraviolet light, again, because of its super tight helical pitch, we should see specific phenomena that just do not affect standard visible light. We're talking about spectral broadening that smears out narrow UV lines in a very specific mathematical pattern. We should also expect to see a loss of contrast in precision UV interferometers. Plus, in astrophysics, we should detect dispersion-like arrival time delays for high-energy bursts, simply because the fluctuating group delay grows right alongside the photon's energy.
But honestly, the true beauty of this entire framework, as Dr. Rehan points out, it matches every presently known experimental constraint. It introduces all these profound underlying mechanics, but still perfectly reproduces every single precision tests of special relativity and quantum electrodynamics we've ever done. It doesn't break our current models. Instead, it embeds them as a low-energy projection of a much richer, geometrically complete ultraviolet reality. It finally solves the paradoxes of the extremely small by giving space an actual physical structure.
So I really hope this explainer has completely shifted how you look at the light around you. We've gone from picturing empty space and point particles to visualizing this dynamic, breathing web of filaments, where color is quite literally just a tighter spiral of energy wrapping around the dimension of time itself. It really leaves you with a profound question. If the very vacuum of space is this intricately woven, what other invisible mechanics are dictating the fundamental rules of our universe? Thanks for learning with us today, and as always, keep questioning the fabric of reality.